welcome to CoJo's Pre-Algebra. Like my hat tonight? Okay, so tonight we're talking about rational numbers and decimals. Well, it's actually during the day because you're watching this, I think, in school. So what do we know? We're going to be talking about rational and irrational numbers and then decimals. So pay attention. First of all, rational numbers can be written as a quotient of two integers, which would be, you can write a rational number as a fraction. That's all that means. Quotient of two integers is a fraction. So therefore, an irrational number cannot be written as a fraction. All right, so we've got some examples. I have 4, 0.5, and -3. Those are all rational numbers because they can be written as fractions. We can write 4 as 4 over 1, or 40 over 10. 0.5 is 1/2. And -3 is -3 over 1. -6 over 2. But the negative has to be in the numerator or out front for a fraction. It can't be in the denominator, remember. Okay. But now those are all rational numbers. Now, remember the heading, the main category here is real numbers. Both rational and irrational numbers are real numbers. Because rational numbers make sense, because we can find those on a number line, because they are fractions. We can rewrite those as fractions. Irrational numbers are on a number line. We don't know exactly where they are, but we know they're there. For instance, the square root of 2, 1.4142135. There's no pattern to that. It's a non-repeating decimal. It's a square root. But we know that it's somewhere between 1 and 2 on a number line, and it's closer to the 1.5 mark, but not quite. It's about 1.4. So we can estimate where it is, but we don't know exactly where it is. But it's considered a real number, even though it can't be written as a fraction. So therefore they call it an irrational number. So there's three types of rational and irrational numbers, or real numbers. There's terminating, repeating, and non-repeating. Terminating, this is all referring to the decimals part of the numbers. Terminating is when the decimal terminates, like 1.5. 0.5 is a half, so it terminates. Excuse me. So terminating decimals are when they end. 1/8 is 0.125. That's terminating. It ends. A repeating decimal is like we get when we do 1/3. 0.33333 and forever and forever, so on. 2/3, 0.66666, right? Okay. Non-repeating are always associated with irrational numbers. Non-repeating are always associated with irrational numbers because they have no pattern. We can't write them as a quotient of two integers. They are, and can't be written as fractions because there's no pattern to write it. So terminating and repeating decimals are always rational numbers, and non-repeating are always irrational numbers, and they're always square roots that don't come out even. Like the square root of 4 is 2. That's a rational number. But the square root of 2 is not rational. It's irrational because it has a non-repeating decimal. Okay. Got that? Very important to understand the language. See my new guy? I have a turtle over here. Okay. So you're going to learn that we're going to write decimals as fractions. 0.45. That's pretty easy, right? Because it's 45 hundredths, so you write it as 45 over 100, and then you have to simplify it to lowest terms. So it comes down to points. But 0.3, I know it's got the hashtag over it, which is repeating decimal, just to show it to you. That's not so easy. Now, you know 0.3 repeating is 1/3, I hope, and 0.6 repeating is, 2/3. But what do you do when you don't know what it is? You have to be able to show me mathematically what the fraction is for the repeating decimal. Well, we're going to show it with, there's 3 steps that you do. Step 1, you write an equation. You take the repeating decimal that you want to find the fraction for. So we have 0.3 repeating. So I write x equals 0.333 with an ellipsis to show it goes on forever. That's the pattern. That's an equation because it has x equals. Then we're going to look for step 2. We're going to multiply both sides of that equation and create a second equation. I know it's confusing, about how many digits repeat. So in this case, the 3 is repeating. That's 1 digit, so that's a tens place. So we're going to multiply both sides by 10. So when we do that, we're creating a second equation. This is the original equation, and then we're going to create a second one by multiplying both sides by 10. We're manipulating the equation to get an end result of a fraction. So we multiply both sides by 10, we get 10x equals, we move the decimal point, 3.333 repeating. The third step is we're going to take the original equation, what x equals, and we're going to subtract it from the one we just created. Just bear with me because it'll begin to make sense. So we subtract, we say 10x minus 3.333 and so on, minus x equals 0.333 and so on. So 10x minus x is 9x. And 3.333, well look, these cancel. The decimals cancel. And we're left with 3. 9x equals 3. Well, now it's just algebra. We divide both sides by 9, and we get x equals 1/3. We've just proved how you can find 1/3 out of 0.333 repeating. Let's go on to one that's more complicated. Okay? 0.045454. All right, so I'm going to step 1 is to make an equation saying x equals my repeating decimal. X equals 0.045454 and so on and so on. Now, the repeating decimal is 45, not 0.45, but hold on to that thought because some of you are already thinking ahead. That's okay. So I'm going to multiply both sides by 100 because my repeating decimal is 454545 and so on. So I write the equation again, but I multiply by 100. So I get 100x equals, and I move the decimal 2 places, and I get 4.5454. Now I subtract the original equation, where I set x equal to the repeating decimal, and I get 99x equals 4.5, because look, this cancels. And I subtract 4.5. Now some of you may say, oh, I see a shortcut. That's fine, because I have a decimal here. And I'm going to have to divide both sides by 99. But I don't want to use a decimal because I have to have integers in my fraction. Remember, rational numbers are expressed as the quotient of 2 integers, not this. This is a decimal. 4.5 is not an integer. So I'm going to multiply both sides by 10 to clear that 4.5. I can do all kinds of things with equations and manipulate as long as I do it to both sides. So I get 10 times 99x equals 4.5 times 10. I get 999x equals 45. Divide both sides by 990, and I get x equals 1 over 22. If you go to a calculator and go 1 divided by 22, you'll get 0.0454545 and so on. But this is showing you that you can always find the fraction for a repeating decimal. All right, now I want you to pause the video, and I want you to try this one. If you want to try, if you figured out a shortcut, what I've done, I just like to walk with smaller numbers. You know that. But that doesn't mean you have to. So here we go. You try 0.0227272. Pause the video. When you're done, turn back. Look it up. Turn the video back on and check the work. Okay. Welcome back. Let's see how you did. Did you get x equals 144? Great. If you didn't, check your steps. This one's tricky because it goes, our repeating decimal is 2727, and we have a 02 before that starts. So you might have multiplied by, I like to break it down to smaller things, multiply by 100, I got a decimal, multiply by another 100. You might have multiplied by what? 10,000. It's just that you have larger numbers to work with right away. But, I don't care. So check this. And now, if you have any questions, pause the video and check your work to make sure you show all the steps, because this is critical. This is manipulating an equation. Manipulating an equation. It shows you what you can do, how much being able to manipulate an equation is to your advantage. It lets you solve things in different ways. So anyway, write down 2 things that you learned and 1 question that you still have. And if you finish this in class today, or you're doing this at home, you do have homework. So let me give you your homework right now to do on top of this so we don't get behind. Okay, I can't find it. So I will give you that homework assignment in class. So when you finish the video, get the homework assignment. But if you're not, you'll have the homework assignment already. Have a great night, and I'll see you tomorrow.